So in question number 18, it is given that an ideal gas is initially at temperature T and volume V. In case of isobaric process, a quantity X is defined as X is equal to dV upon V dt, where dV and dt is a small change in volume and temperature respectively. If graph between ln x and ln 1 by t is shown in figure and n is equal to tan theta, then find the value of n. So it is given in the question that the gas is ideal. So we know that for an ideal gas, PV is equal to nRT. And since the gas is following an isobaric process, so P is equal to constant. So if I differentiate this equation, then P into dV is equal to nR into dt. So from here, the value of dV by dt comes out to be nR by P. So in the question, a quantity X is defined as 1 upon V into dV by dt. So if I substitute the value of 1 upon V, it comes out to be P upon nRT into dV by dt, that is nR by P. So if I solve this, it comes out to be 1 by T. So if I take ln x, then it is equal to ln 1 by T. So it is a straight line between ln x and ln 1 by T. So the slope of this line is 1 and this angle is equal to pi by 4. If this angle is pi by 4, then this angle is also pi by 4. Then the value of theta is equal to pi by 4. So capital N is equal to tan of pi by 4 and it is equal to 1. So the correct answer for question number 18 is 0, 1. Let's move to question number 19. In question number 19, 27 number of identical cells, each having internal resistance 1 ohm, are connected in series and parallel combination as shown. Our external resistance R is equal to 3 ohm is connected between A and B. Value of M, that is number of vertical rows, and N, number of cells in each vertical row, are taken in such a way so that current in the external resistance is maximum. Find the value of 2N. So if I redraw this given circuit, then the equivalent can be replaced. Since there are n cells in a row, so the EMF of the battery will be Ne and the internal resistance is N into R, where small r is the internal resistance of each cell. So these vertical rows can be replaced in this way, and this is my point A and B, and in the last it is connected with the external load resistance capital R. So if I replace again, then this circuit can be further redrawn into equivalent circuit. So the EMF of the battery would be Ne and the R equivalent of the complete circuit is equal to NR by M, and this is my point A and it is my point B, and it is connected to the external load resistance capital R. So we know that M into N is equal to 27 because the total number of cells is 27, and from maximum power transfer theorem we know that for the maximum current in the load resistance, here the value of internal resistance of the circuit, that is NR by M, must be equal to the resistance of the load, that is equal to R. If I substitute the value of internal resistance and external load resistance, so on solving, the value of M comes out to be N by 3. So if I substitute this value here, then N by 3 into N is equal to 27. So from here, the value of N comes out to be 9 and the value of 2N is 18. So the correct answer for question number 19 is 18. Let's move to question number 20. In question number 20, a part of circuit is shown in figure. Find the value of VA minus VB in volt. So it is given in the circuit. So 2 ampere is coming from this way and 1 ampere is coming from this way. So here it will go 3 ampere. this 3 ampere will move in this fashion, and up to here the 3 ampere will come. After that, at this junction, this 3 ampere gets distributed. In upward branch it goes 1 ampere, and in this branch it will go 2 ampere. So I can write VA. So if I move from this point to this point, there is a drop of potential 4 volt. So minus 4. Again there is a drop of potential as we move in the direction of current. The value of resistance is 2 ohm. So 4 ohm, 2R is 4 ohm. So 4 ohm into 3. So minus 12. Then there is a gain of potential of 8 volt plus 8. And again there is a drop from here to here. So R is 2 ohm into 2. So minus 4 is equal to VB. So on solving, the value of VA minus VB comes out to be 12 volts. So the correct answer for question number 20 is 12. I wish you all the best for your preparation. Have a good luck. Thank you.